afternoon. Let's continue. Okay. Now we're going to talk about computing paradigms, and the idea is for you to understand. Was one of the examples when we were talking about when we were on the previous lecture that was related with, in this case, the use of computing paradigms. Okay. Okay. This slide here, or the idea here, is to justify, in this case, or to motivate the need for using, in this case, computing paradigms, because we have seen, if you remember, we talked about vehicular networks that we couldn't actually just do some, or at least add intelligence in this case into the network. That's why we needed to, or at least it was necessary to go, or to after some development, to propose a new concept in this case that was termed Internet of Vehicles. Okay, when you're talking about Internet of Vehicles, you need to think, or even vehicular ad hoc networks. You can think of because you have this Internet of Things, and then you have Internet of Vehicles. Okay, it's somehow some sort of a specialization of the Internet of Things, just targeting vehicular objects. Okay, and but because we have all these objects that constitute the vehicular network in this case, or it is a connected vehicle network, and this brings some additional challenges, such as the heterogeneities, as we have seen, or even, for instance, the types of services that we can, or that could be enabled in this type of networks, or even when all these devices and sensors that are actually a part of this network start collecting all this data. Okay, how exactly you can, in this case, then perform some sort of data analysis, or even use these sort of algorithms in order to extract some useful information to help, in this case, users of connected vehicle networks. Okay. What happens here is that the idea of, or at least of using computing paradigms is so that this information, or at least we can have a good mechanisms in this case to process this information, or even to make something useful of it. Okay, we start here just by defining, or in this case, the concept. Okay, or at least by introducing this concept of a paradigm. In this case, that's nothing more, nothing less. That's the way of seeing or understanding a particular thing, and then by using, for instance, computing paradigms, we can actually solve problems of data availability in this case. Okay. Because you may have, in this case, depending on which part on where you are, you may want to perform a given a given set of or apply a given set of techniques, or to extract information, or a knowledge, or to display this information that you are that you have extracted by using these algorithms in a specific way, and by doing so. Okay, or at least by using computing paradigms, in this case, you can store and analyze, in this case, and then produce relevant information based on the information that you have collected. I will now briefly introduce, I believe that most of you are aware of the cloud computing paradigm, okay, but I will briefly introduce this concept, okay, because when you're talking about cloud computing, okay, the goal here is, as you can imagine, is because what happens that you have, of course, a set of resources, in this case, that computing power, and what you want to do, you want from your users, your customers, to be able to make use of these resources. Okay, but the way, or at least how they use this, should because one of the big problems is when you are comparing, for instance, what happens in the old days was that each company, or at least at each company, you needed to have some sort of an IT guy. Okay, you would need to buy, for instance, servers, and you would need to install all your services. In this case, your intranet, your webmail, and all those important services for your institution to work properly. Okay. Nowadays, what happens is that you don't need to buy hardware. The only that you need to do is that you need to hire these services from Amazon in this case, or even from Microsoft, or from Google, or even from Alibaba. Okay, I believe that of course there may be other players, but these are the main ones. Okay, there are a lot of benefits when you're talking about cloud computing, such as driving costs down. Why? Because now, instead of you having that initial investment of buying hardware, you don't need to buy hardware. You just go in. For instance, I will focus more on the Amazon Web Services, because what happens there is that you have these EC2 machines. Okay, these are basically virtual machines that you can actually pay to have, and depending on the requirements of these of what you need, then you can pay more for that specific thing. Okay, in this case, it drives costs down. Then there is this accessibility, productivity, and scalability, because if you need more, then you can ask and pay for more. Okay. Then you have automatic updates, because then you just have to inform the cloud provider. Okay, or at least you don't even need to inform them. They are the ones that will basically manage the infrastructure, and if some updates are necessary, are needed, then they will actually do it for you. Then we have your business continuity in this case, and you have pay structure, because you pay as you need. Okay, you don't need to buy a very expensive server and just use part of it. You just, if you need virtual machines in this case, you just buy them, and if you need more, you ask them for more. Okay. And we have in this case the common characteristics. In this case, that's one of these is the on-demand self-service. That's what I mean. What I mentioned. By on-demand self-service, we're just here saying that okay, if you need something at a given instance, then you go there and pay for it. In this case, you just need to specify. I need a machine with this set of characteristics, and then you just. And they will give that to you. In this case, measured service, because if, for instance, you specify that I want 16 gigs of RAM, 100 terabytes of hard drive, you need to have a way of checking if, of course, over time you are actually if this is what they actually provided what you asked for. You have here rapid elasticity. And elasticity is actually a very good solution for that problem. You remember when I told that if it was AWS or Amazon, that problem of the servers crashing wouldn't happen? It's because of the elasticity. If you have high demand at a given moment, because of the elasticity, what will happen is that if you need, instead of just one, you need 2 servers because you have more demand, then they will do it for you. For you as their customers, it's actually transparent. You just say, I want to ensure quality of service, that I'm able to answer all those requests timely, and they will actually provide. And if for a given reason you don't need more resources, what will happen? You just say, okay, now I don't need. Okay? And you don't need to pay extra for that. Then we have here resource pooling. This is actually some sort of a continuation of what I was saying, is that, okay, now you need 2, okay? they allocate that to you, and then you say, okay, now I don't need a second, I will continue only with the first server. What will happen is that those resources that were allocated to you then will be allocated to another user. Sorry. And then we have, of course, broad network access. Okay. This mainly means that you can access, or at least you should be able to manage your virtual machine wherever you are just by using a web browser. Okay, simple as that, by clicking on that. Okay, then we have here some sort of the deployment models for cloud computing. In this case, we have the private cloud if this belongs to a given corporation. Okay, and only the staff in this corporation can actually access to this cloud. Then you have the public cloud that everybody can access. We have a community cloud, as you can see here. You may have different corporations actually using this cloud, and there is a set of policies or requirements that specify how and when it is actually used. And then you have the hybrid, and by being a hybrid, it's mainly a combination of all those. Okay. Then we have the service model. Okay. The service model, okay, because we are talking about cloud computing, are actually three types. What you have here, you have infrastructure as a service, and this is Amazon Web Services model. Okay? Because here, what they do, they give you resources. You need a virtual machine with X gigabytes of RAM, Y gigabytes of space, and I think they allocate you resources, and then you do with that what you want. You can even specify, okay, I want to install this or that specific operating system in that specific virtual machine. Okay, you have, as you can see, more flexibility. Then what happens here, we have platform as a service, but as you can see, platform as a service is in here, and what happens is that the cloud provider gives for software developers, their platform in this case gives them an API, and they will have to do development considering what this API actually enables them to do. You have one example of this, if I'm not wrong, Azure. Microsoft Azure, it's one of the examples of this case here. And then we have the last model, that is software as a service. Okay, and this is the most restricted model. Why? Because here you just have a software and you need to use that. You can only basically use that. You can just fine tune A or B considering your account. And this is actually one of the most common. And as you can see here, you have an example. It's actually Gmail or even Office 365. Okay. Now we are you are already specialists in cloud computing. Now let's talk about fog and edge computing. Okay, because cloud computing is actually quite nice. It enabled a lot of things. In this case, you are able to store your data. But if you want actually to do some sort of additional processing, if you want to send data to be processed, then you have a small little problem that is related with delay, because you need to send that data over the network and you don't know exactly where data center it's located. Okay, and this may have some influence in real-time applications. Okay, that's why in this case we use these other computing paradigms. What we have here in this case is that instead of sending data some place in the world, okay, where the data center is, then what happens here is that most of these providers of edge and for computing, they actually install, when we're talking about principally, mainly when we're talking about edge computing, you have computing power at the edge of the network. When talking about edge of the network, if you consider that example that I gave you of 5G networks, then at the base stations you have their processing power. Okay, therefore, if, for instance, you are using your phone and you want to send data to be processed, then instead of sending to the cloud, it will be sent to the edge. Okay, and as you can imagine, the edge is by far closer than the cloud. Okay, and here we have, in this case, regarding the tiers, you have in this case um, um, here what happens is that you have the edge devices. Let me just see regarding, because this is regarding, yes, number. Okay. Okay, regarding the tiers, what you have here, you have the user tier, okay, where you have most of the user devices, okay. Then you have the fog tier, okay, and the good thing here of this fog tier is where you actually find this some network nodes, okay, because by using this network, or in this case nodes that you can actually send data, and because depending on what you do, some processing can be done at the edge or fog layer, or even you can also send data for further processing to the cloud. Okay, that's why then you have this three tier architecture. Okay. At one side we have the computing paradigms, okay, and on the other side we want now is to how can we apply these computing paradigms to connected vehicle networks, okay. And this image actually shows a little bit of what we can do here. In this case, this concept of vehicular cloud computing was actually proposed, as you can imagine, or at least imagine that you have, if you consider some sort of a parking lot, okay? The good thing of a parking lot is that you have many cars that are just there for you don't know how many hours, okay? And if you have all those cars there, what can happen is that you can use their computing power to perform some set of operations, okay? In this case of computing task, because there is in this case computing power, or at least processing power available there, and it's actually quite good because then you can perform a similar type of operations that you are performing on the cloud, in this case by using this cloud computing paradigm, okay. And but we have here two possibilities. You can have this one here, that's actually all those vehicles are actually static, okay, they are parked somewhere, okay. And you can have also imagine, for instance, that these vehicles are actually moving, but for a given reason there is some sort of a traffic sign, and they stop for a given instant, okay. Then while they're waiting for the light to turn green, in this case, then some operations can actually be performed over there. And as you can see here, we have also they can use also a roadside unit, okay. That's actually the roadside units usually are infrastructure in this kind of type of networks, because then they can send part of this information to vehicles in this specific location, so that they can give, depending on the task, they can perform this task and then send it back to the roadside unit, okay. The difference here is that this actually is a static vehicular cloud, and in this case these are actually dynamic vehicular clouds. But there is also here another concept that's called vehicles using cloud, in this case VUC, okay. By means of this concept, what we are here saying is that vehicles can actually, if for instance, some processing is necessary or is needed, then they will act, because they are connected to the cloud. They can actually send this so that to the cloud somewhere in the internet, so that this task can actually be performed. Then we have also this concept that's actually the vehicular edge computing, okay, But when we're talking about vehicular edge computing, we are actually using, okay, mobile edge computing, okay, because and this image actually shows, because here we have our vehicles, okay, and because you have roadside units or even base stations, and in this case, if you have here servers closer to the infrastructure, then some tasks can actually be offloaded to the nearest roadside units for processing, and then once it is processed, then this data can be sent to the vehicles. And of course, there are actually applications that can be enabled by this kind of very interesting applications. For instance, augmented reality. Okay, you are arriving in a given location, and then they are basically there you are receiving additional information of the types of services that are available in that specific location via augmented reality. Okay, this is actually these are some sort of location-aware services. This image actually shows it all. What do we have here? We have vehicle cloud. Okay, vehicles. This is in this case a static vehicular cloud. You have many vehicles that are actually parked here. You have also this is the base station, and as you can see here, you have some sort of processing capability. You can also have here, depending if these vehicles are here actually they stop here because of a traffic light. Then what we can have here, we can have here a dynamic vehicular cloud, and we have the other thing here that's actually quite far away. That's the normal cloud. Okay. What happens here is that to send data over the internet until here, this can be, of course, because of latency, this can be a little bit difficult, considering those or at least the type of application that you have in mind for this, or the type of service that you have in mind for the specific case. This table compares these two protocols. In this case, what we have here, we have VCC and Vecor VFC. In this case, this one is a little bit remote, as you can see here on this image. This is, if you consider that you have here the road, this is a little bit more remote, and in this case, Vecor VFC, in this case, it's actually quite near. And in terms of latency quality, okay, this is a little bit lower than this, because this tends to be, in this case, much more closer to the users. And then in terms of communication, this can be done in real time. If communication, or at least this is in real time, then what will happen here is that this enables real time applications. Okay, of course that here you can also have offloading services. And in this case, in both cases, you can have offloading services because it's the offloading services enabled, for instance, applications such as augmented reality. Okay, and in both cases, we have that the computing power is actually quite good, but of course the costs are actually different in this case, because here, as you can see, you have vehicles coming and going, and here you have a set of vehicles actually that are parked in a given location. That's why this tends to be actually lower in terms of costs. We have, of course, that if we go back and remember, for instance, if you go back and remember, we have here these two technologies, in this case 5G and Wave, the Wave standard, that they tried, in this case, for the case of 5G, they tried to at least to address the requirements that were actually specified by ITU and METIS in this case, regarding, for instance, throughput, latency, because here the idea is to have very low latency in this case, because of the type of applications that you are actually wanting to enable. And and we have here another aspect such as both VCC in this case, vehicular cloud computing, and vehicular for computing in this case, because depending on the application that you want to enable, it may be necessary to have something that's called types of service, or even priorities, depending on which data is actually more important. Okay, both these paradigms actually enable this kind of differentiation between the type of traffic. Okay, and if you remember, there's actually there's some difference between VCC and VUC, because VUC, it stands for vehicles actually using the cloud. Okay, not a vehicle cloud computing itself. And in this case, conceptually, because in order for you to have vehicular fog computing, you need to have these fog nodes. This actually do not mean that every node or every object that actually constitutes a vehicular network actually belongs to, or at least it's part of the vehicular of a given paradigm. Okay. And the other things here is that this one here is actually quite interesting, because here what we are stating here is that if you have, for instance, both 5G and wave available, what you could do, and if you remember that we mentioned about that kind of prioritization of the traffic, what could happen here is that you could use, for instance, 5G to send real-time data using vehicular fog computing in this case, because by using VFC you can enable real-time applications, and at the same time you could also send here low priority data in this case using base stations. Okay, therefore you could have two ways of sending information for this, so that this information could be processed and therefore enable these fantastic applications. But as you can imagine, there are not only good things when we're talking about computing paradigms. In this case, we have here also additional challenges. Okay, for instance, interoperability. Okay, because what happens here is that over time, or at least what we are proposing today, can be outdated over time, or at least you can have competing teams, in this case proposing different network architectures, and therefore these may bring additional challenges. But one of the main challenges that we are still facing here is the amount of information that's actually being generated by these devices. Okay? Because if we are, imagine that we have, in that specific scenario, we have like 10,000 vehicles. All those vehicles are actually gathering data, and they need to send this data. Then we have a problem. If you even consider that, okay, we are using 5G, and you were able, for instance, to download, okay, because there you have uplink and downlink. Usually, what is higher, uplink or downlink? Uplink is for you to send data. Downlink. It's okay. You can download at a higher speed than you can actually upload. Okay. What is the influence of that? Is that if you have too much information to send, then you have problems sending all that data. And imagine 10,000 vehicles sending all this information. Then you may have a problem. Even while considering 5G, it's a lot of data. Okay? Then the other problem here is that we need to be able to send this data to a given location. Okay? How are we going to do that? We're not going to be sending, for instance, imagine 1 terabyte
per day to a processing station. Okay, it's a lot of information. Okay, that's why. Okay, finding in this case intelligent routing or route planning could be can be quite handy in this case, or in defining in this case good paths in order for you to be able to send your data. This could be good. And then, besides that, there is also another challenge. Okay, okay, you are able to collect all that data. In this case, big data, and then you were able to send that data. Then you have another problem, that is processing all that data. Okay? Because if you are sending that data daily, then you have a problem. Are you aware of, for instance, these images that are captured by the, or were captured by the Hubble telescope? Sorry? Yes. How long it took to process that data? And then start doing what? Fun things with the data. Okay, to process and see, okay, this most probably is that. Okay? A lot of data, a lot of, requires usually a lot of computing power. Okay? Then we have, of course, this is a consequence of this that we are talking here. It's mainly network saturation. Okay? Because the interesting thing here is that is just vehicular data. Okay? We have other data that it's being collected and also needs to be processed. Right? Therefore, network saturation. That's why we are now talking about 6G. Because, okay, 5G is quite nice. We can do interesting things. And, how many of you actually have a 5G phone? Okay? Like 10. Okay? That's what's happening in the world. Not many actually have 5G phones. That's why you still can actually use 800 or 500 megabits per second. If everybody starts using, then it will drop. Okay? And then we have here that still we have that physical barriers in this case also has some sort of influence in the quality of the signal, and of course there is this problem with the spectrum, because imagine that 40 years ago they were offering spectrum to everybody because there weren't many applications. Nowadays what's happening is that because they basically offer the most of the spectrum, they have problems managing because as you can see now they allocated spectrum for 5G, they will need to allocate spectrum for 6G, for 7G, and so on. Okay, and this is, as you can imagine, a limited resource. Okay, and of course the other one here is mainly this is actually inherent. It is actually related with because we're talking about a vehicular network, and nodes in vehicular network, they are actually moving. Okay, and because they are actually moving, this adds extra challenges to our equation. Let's see now two interesting applications in this case. We have this first one, that what we want to do, we want to optimize resources. What happens is that, yeah, but you are students, but it doesn't matter, different backgrounds. How many of you have used an electrical car? Electrical bike, bicycle, something electrical, or even what is it? There are a lot of those where you just pop in and then you just, what is it? I'm forgetting. Sorry. not a scooter, because a scooter is like some sort of a motorbike. No. Ah, okay. What happens here is that, okay, but you were aware of the electrical vehicles, right? Good thing, right? Pollution, almost no pollution, right? But you have an issue. You need to charge the thing, right? Right? You are not aware of. It's simple. If you go to a gas station, you are like 10 minutes. Shh, done. Go. For electrical vehicles, not like that. You arrive into the station first. You need to know if you have a slot, a place to charge your car. And the problem here is that if you check the app, okay, it's free now. You go there and you arrive, it's occupied. Okay? It's a little bit frustrating, believe me. And then you can go from this charging station into another charging station, and everyone you go, it's actually occupied. And as you can imagine, the battery on your car, it's going down. Okay? Are you seeing? Then, actually, these guys, what they try to do, they try to optimize that problem in this case. What they try to do is by using, in this case, vehicular edge computing, they try to avoid for drivers to waste time and battery looking for charging stations. Okay? Interesting things that you can do. And this other application here, it's actually location aware, in this case, carpooling. Do you know what carpooling is? What is it? Shh. Oh, you know it. Nice. Good. Okay. Why is it important? Why?
It's convenient as you traveler can save some money, but on the bigger scale, it saves a lot of space on the road.
It saves a lot of space on the road, but of course you will be sharing your car with, you don't know. It's okay, but it's actually quite good. Okay, by using this app, in this case, as your colleague indeed mentioned, if in this case there are others that are heading the same way, then you can actually share your car. It's actually environmental friendly. Okay, it's a good thing. Okay, in this case, as you can see, by using computing paradigms, you can actually do very interesting things. Okay, but are you? What's this? Blockchain, right? We needed. It was necessary to add here blockchain because we need to have, for instance, some additional properties to ensure that this scheme actually works as it's actually supposed to work. Okay? And as you can see here, blockchains guarantees auditability, privacy, and security. Okay? And by doing so, we actually concluded the second part. Do you have questions? No? Okay, good. If you don't have questions, then let me just give you a glimpse of the third topic. In this case, that is cybersecurity. Okay? What is the problem when you're talking about cybersecurity? Okay? The main problem here is that you have, we can say on your left side you have attackers, hackers in this case, and on the right side you have good guys. Good guys are those guys that want to enable new services, and the bad guys are the ones that want to exploit, or in this case find vulnerabilities so that they can profit from those vulnerabilities. Okay? The problem here is, as you have seen, how many usually travel by plane? How many are on a given plane at a given instant? More, or depending on the size of the plane, you can have more than 200 people, right? If something goes wrong, you may have a lot of fatalities, right? Um, that is why it is actually always important to consider cybersecurity. Okay? And this image here actually shows it. Okay? As you can see, you made a fantastic car, but you forgot that, okay, they may steal it. Right? Then, okay, what can I do? Solved. Okay? That's why I wrote here, adding security as an aftermath is rarely pretty. Okay? When you're talking about cybersecurity, you need to talk about its requirements. Okay? In this case, requirements are confidentiality. You are trying to ensure that no one is able to see what, or should be only, for instance, legitimate users should be able to see what's being shared. We're talking about availability. If you have, for instance, the good example is that one of that web application. Okay, if you are selling, for instance, if you are doing a sale, and what you need to ensure is that your server, your web server, it's up and running. Because if it crashes, then you have an availability problem. Data integrity, okay? If you have, I'm not sure if you have heard of this man in the middle, okay? If there is someone listening to what you are sharing, what can happen is that this third guy can then act as an intermediary. You send your data, and this guy tampers it and forwards it. Okay? And then we have also here non-repudiation. Okay? Because if I sent you that data, what I'm expecting? I'm expecting to, or at least if someone sends you something, then you are not expecting for that same person then to say, no, it wasn't me, no, it wasn't, it was that other guy. Okay? We have here also authentication, okay, because this is actually good, because all users that, do you remember, for instance, we're talking about vehicular ad hoc networks where we had that third or trusted authority that was actually was the one that guaranteed that anyone that was in the network was actually an authentic user. This is very good because then if you only have authentic users, then it will be easier to identify who did what. Okay? Then you have your access control, and the good thing of access control is that then you know if someone among all these users of your system who did what, because or at least not specifically, when you have access control, what happens is that your users are only supposed to do specific things, okay, because they have specific roles. Yes. And then we have privacy, okay. In this case we're talking about privacy. We don't want actually to be disclosing, or anyone want to be disclosing their personal or sensitive data. Okay? We are nowadays getting too sensitive about privacy. The problem here is that if you want services, sometimes you need to give information. Otherwise, it will be a little bit difficult, okay, to provide some services. Okay, for instance, location-aware services. If you want location-aware service, you need to be able to share your location. If you don't share it, how are they going to provide you that information? It's difficult. Okay. Okay, but we have here, when we're talking about vehicular networks, we have some challenges. Okay. For example, low tolerance to errors in this case. Depending on the type of application that you want or that we need to enable in this case, and considering we are talking about vehicular networks, if there is a problem, this may lead. Imagine that a vital system on a given car malfunctions, or critical, an airplane malfunctions, then you may have a serious problem, right? The good thing is that airplanes usually they have redundancy, but you don't have redundancy in cars. No? Okay, then we have here the other thing that's key management. What's the big problem of key management? Is that if you have 100 cars, having 100 cars is different of having 1,000 cars. That's different of having 1,000,000 cars. Okay, you normally need to generate pairs of public and private keys, and then depending on the application, you also need to be able to manage the certificates of revocation. If these keys or are stolen or actually get because usually what happens is that you have some sort of a duration associated with the certificates, and when they are not valid anymore, then they need to be revoked. Okay. Then we have here high mobility that you already know. That's actually characteristic in this type of networks, and this problem here is what I've actually mentioned, this paradox between security and privacy, because if you want services, then you need to be able to give some information. Otherwise, it will become really difficult to provide you that kind of services. That's why nowadays, when you call for instance, help desk, they ask you, can we record your call or this call? Or they usually say, if you don't want for us to record this call, please contact us using another means. What do they mean with that? You need to go to a store and talk directly with someone, because by doing so, they won't be recording what you're saying. And the last one here is, in this case, cloud stability, security, and in this case, in privacy, because here we are talking about what we can enable, or in this case, big data and high performance computing. In this case, these can be quite useful, okay? And the problem here is that if we don't apply efficient encryption algorithms, because if you want, for instance, to send data securely and considering the amount of data that you are wanting to send, then we may have a problem, okay? The problem, the other thing here is that you always have malicious users, in this case attackers, that will always be trying to do funny things with our data, in this case compromising our security. That's why most of the times you need always to consider security as one of the most important requirements everywhere, not only in connected vehicle networks. Okay? Okay, see you on